Just as this chapter seems to be getting weirder and weirder, we seem to be taking a real strange turn here with binomial expansion. I'm always amazed that students haven't seen binomial expansion until this course. But binomial expansion is just the idea that if you took x plus 1 to the third power, you know, that's x plus 1 times x plus 1 times x plus 1. Well, what is that? Well, it's x to the third plus 3x squared plus 3x plus 1. Well, is there a way to somehow go from this right to that without having to multiply those out? And the answer is yes. It's binomial expansion pattern and binomial expansion formula, which we're going to look at right here. It's starting kind of an interesting thing. Interesting, sounds like a puzzle, but it's actually a perfect intro. Let's say you want to go get a pizza. You're at home here, and you're going to go to Domino's. Okay? There's the old-fashioned block system to your town, and now with cul-de-sacs this doesn't work, but the old block system, the shortest distance is to go over and up. Over, let's say, 5 blocks and up 4. And you might say, okay, that's the shortest route. But how many of those short routes are there? Because you could go up and over. You could go, you know, zigzag. You can do a little less zig, but still do a zag or two. How many of those shortest paths are there? We'll stop the video, try it, and see what you come up with. All right, here's the answer. The answer is if we start here at A, there's one way to get to this point. One way to get to this point is straight across. One way to get here, one way to get here, one way to get here. Same in the vertical. To get to this point here, get to this point where the dot is, you could either go over and up or up and over. So what happens there is that 1 plus 1 gives you 2. To get to this dot, you can go over and up, that's 1, up, over, over, up, all the way over. 2 plus 1 is 3. And then this will be 4, this will be 5, this will be 6. This will be 3, this will be 4, this will be 5. Now, to get to this dot, very interesting, you have to go through this place and this place, or this place. So I'm going to go 3 ways to get here. 3 ways to get here gives me a total of 6. So you can see how this sum method comes to play, giving you each intersection, again, 25, this will be 35 here, 15, 21, 35, 70, 56, 126 ways to get from A to B, shortest route. It'd be longer if you double back, but we're excluding those. So if you turn this on its side, you get something familiar, which we refer to as Pascal's triangle. Pascal's triangle is a way that we're going to use to find expansion coefficients. So watch this. Let's say we took A plus B to the 0. That's just going to be 1. Let's say we want to go A plus B to the first. Well, that's going to be 1A plus 1B, right? A plus B to the second is going to be 1A squared plus 2AB plus 1B squared. Okay? And those are added, of course. and a plus b cubed, we can use this pattern. We know we're going to have an a cubed and a b cubed at the end. In between, we're going to have an a cubed b and an a squared, let's see, a cubed, no, we're going to have an ab squared and a b a squared. So this is going to be 1 plus 2 will give me the 3, and this will be a 3 as well. And of course this is a cubed, a squared b, ab squared, and b cubed. Very easy to see my pattern here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and the next a b to the fourth will be 1, 4, 6, 4, and 1, and you can keep going and going. This method is how we're going to expand binomials with what I call a pattern expansion. So a plus y, x plus y to the fifth. The way I like to do this is a descending x, x to the fourth, x to the third, x to the second, x to the first, x to the 0. Then do an ascending y to the 0, y to the 1, y to the 2, y to the 3, y to the 4, y to the 5. For the coefficients, we employ Pascal's triangle and go to the line that has 5s in it. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, and 1. And there's how you use Pascal's triangle to expand a binomial. This will be simplified to x to the fifth, 5x to the fourth y, plus 10x cubed y squared, plus 10x squared y cubed, plus 5xy to the fourth, plus y to the fifth. The simplification step is helpful. Well, that's easy, you know, if you have just x and y. But let's say we have something that's a little more complicated, 2c and negative 4 over d to the third. No problem. We're going to start off with descending x's. Call this x, call this y. 2c to the third, 2c to the second, 2c to the first, 2c to the 0. Then go negative 4 over d. Over d to the 0, negative 4 over d to the 1, negative 4 over d to the 2, negative 4 over d to the third. Then Pascal's triangle, go to the third, which is easy. We know that one pretty well. 1, 3, 3, 1. And then the simplification step is the one that's going to take you a little while here. 2 cubed is 8c cubed. Anything to the 0 is 1. Negative 4 times 4 is 16 times 3 is negative 48 c squared over d. Negative 4 squared is 16 times 2 is 32 times 3 is a positive 96. Notice how the negative signs alternate. C over d squared. And then the last one is negative 4 cubed, which will be negative 64. 2c to the 0 is 1 over d to the third. So that's the expansion using the descending x's, the ascending y's, and then the coefficients from the Pascal's triangle. and that's using the pattern to expand. We're going to use a formula that uses factorial in a little bit, and factorial is the idea that 5 factorial is 5 times 4 times 3 times 2 times 1. And if we had 3 factorial, you'd have 3 times 2 times 1. If you divided these, you can see that these will cancel, leaving you with 20. So if I had 100 factorial over 98 factorial, you can kind of see that the 98, 97, all those are going to cancel out. You'll get 100 times 99, which will be 9900. 0 factorial is equal to 1. So that's kind of strange. And then k plus 2 factorial, that's equal to k plus 2, then it's k plus 1, then it's k, then it's k minus 1, and it'll keep going to forever. And I'll give you that hint for D, because if we divide by k minus 1 factorial, we're going to get k minus 1, k minus 2. All of these are going to cancel out, leaving this behind. All right. So the last thing we're going to look at is the idea of a binomial coefficient. Those coefficients on Pascal's triangle are great, but wouldn't it be great if you didn't have to use the triangle? And the answer is there's a way. You can do that by something called the binomial, we use it, combination formula. And what you're doing is you're taking the n, the top 1 factorial, over the bottom 1 factorial, over the difference factorial. So of course 5, choose 3 is 5 factorial over 3 factorial over 5 minus 3 factorial. So if you have 8, 6, it will be 8 times 7 times 6 times 5 times 4. Well, let's do it this way. This is going to be 8 factorial over 6 factorial over 8 minus 6 is 2 factorial. So these two together will be 8 times 7. All the 6, 5, 4, 3, 2, 1s will cancel out over 2, which is going to be 4 times 7, which is 28. All right, so then you'll be able to work on those. That binomial, so what we did is the pattern was descending A's, right, or the X's, and then you had ascending B's, B to the first, B to the second, B to the third, all the way to B to the n. And then the coefficients from Pascal's triangle are just going to be, I think I erased some good stuff here. There we go. Then you can figure these out with the factorial. So one of the things that's annoying about this is that J starts at 0. Because J starts at 0, the power of B starts out at 0. Everything is like one off from what we would think of. So we'll deal with this in a little bit. There we go. So here's a general equation to get any term. How do you know which term you're at? Well, we'll deal with that. So let's say that we don't want to expand the whole thing. We just want to know the 6th term. So when we look at x plus 2 to the 10th, n is 10. The first part of the binomial is x. The second part is 2. And then we want to know the 6th term. Now, J is the power. J is the term that you're at But remember j, it started at 0. So this is going to be the term minus 1. So this is going to be 6 minus 1. The power of b is going to be the term minus 1. So j is going to be 5. So figuring this thing out, you're going to have n, which is 10, choose 5, because it's 6 minus 1. Power of y is 1 less. And then you're going to have x to the 10th, or no, x to the 5th, excuse me. And then it's going to be 2 to the 5th because it's 10 minus 5. Maybe a bad example. Use your calculator to find 10, choose 5. You can go 10 NCR in your calculator, 5, and then it'll just be times 32 x to the 5th, whatever that comes out to be. Some of these numbers will get huge. Okay? Let's do another example. X to the 7th. So the power of 2x plus 3 to the 11th, the power is the 11th. A is 2x. B is 3. Now the term is tricky because we don't know what the term is, but we do know that 2x to the 11th, x to the 11th will be the first term, then it'll be 10th, then it'll be 9th, then it'll be 8th, and then it'll be 7. So this is going to be the first term, the second, the third, the fourth, and this, of course, will be the fifth. So my term is going to be fifth. I listed them out, is how I did it. And then j is the term minus 1. So we will go n, choose j, a to the j times, I'm going to double check this, make sure I'm not doing, nuts. Nuts. This was n minus j times b to the j. So this will be 11, choose 4, a to the 11 minus 4, oh, and a we already know is 2x. A is 2x to the 11 minus 4, and then b is going to be 3 to the 4th. Use your calculator to find 11, choose 4. Don't forget 2 to the 7th power times 3 to the 4th times x to the 7th. So this is going to be 11, choose 4. 2 to the 11 minus 4 is 7. 3 to the 4, x to the 7. So whatever this product turns out to be, and it's huge, that will be the coefficient for the x to the 7th term using this formula. So real quick, when you're doing this, you take the power, figure out what j is, and then use the formula. First part, a to the n minus j, b is 3 to whatever j is. And we can do examples and problems all day long. It's all the same kind of thing. You have to find your j, and you'll be good to go. Let's see. So for the homework, you've got these to do. Use the triangle method for these few. And then we're going to find the term for these. So I'm going to help you real quick with number 18 here. A is the first part, 2x. B is the second part, negative y. The number of terms, or the power, is 5, and the term number we have to figure out. So if you take x, 2x to the 5th, it's going to be x to the 5th, then it'll be x to the 4th, then it'll be x to the 3rd. So it looks like this is going to be the third term. So j is going to be 3 minus 1, or 2. So then use your formula, n choose j, a to the n minus j times b to the j, and then you just go ahead and figure those out. Plug those in and figure it out. Right? So these should go well as 2, and finding the term, you may have to do what I did, like something like this one here to the 6th, you're going to have x to the 6th, then you're going to have x to the 5th, then you're going to have a y, then you're going to have x to the 4th, then you're going to have a y squared, you're going to have x to the 3rd, then you're going to have a y cubed. Finally, you'll get an x squared and you'll get a y to the 4th. First, second, third, fourth, looks like the 5th term. And then j would be 1 less than that. Good luck with the binomial expansion. Used a lot in upper math, and practice them so it becomes real fluid for you.